Assalamualaikum and hi everyone. This is our minor projects and our minor projects titles is Modeling and Crime Investigations. In these projects, we will see how crime investigation will be solved by using modeling mathematics and differential equations. So, let's start. And this is our members, which is myself, Saidatul Aisyah binti Muhammad Sani, Rashaya anak perempuan Ihdam, Evelyn Sarahjin anak perempuan Santanadas, and Nur Izzati binti Syamsul Amran. Let's see our problem statement. As a crime investigator, predict the temperature of a dead body over a 10-hour period. At the time of death, the body's temperature was 36 degrees Celsius. When you arrive at the crime scene at 11 p.m., the body temperature was 25 degrees Celsius. Over the 10-hour period, the room in which the victim died remained at a constant at 15 degrees Celsius. Using the value of K equal to 0.12 per hour and delta T equal to 0.5 hour, we have to compute the temperature of dead body over 10-hour period, and we need to find the time of death of the victim. So, before we solve our problem statement, we need to know the background of the problem. So the first one is, we can solve using analytical method, but obviously it will take so much time. So instead of doing that, we can create programs and solve using MATLAB. As we seen before, we need to find the temperature of the dead body. So in this case, we can use two different approaches, which are Newton's law of cooling and Euler's method. Okay, let's do the question number 1. Compute the temperature of dead body over 10-hour period. Okay, let's see the first approach. Newton's law of cooling states that the rate at which the objects cool is proportional to the difference temperature between the object and surroundings temperature. And this is the formula, which is T prime T equal to negative K Tt minus Ts, where K is a constant that depends on the material properties of the objects, and Tt is the temperature of the object at the time T, and Ts is the constant temperature of the environment. Notice that the negative sign beside the K indicates the heat loss.
Let's look at the MATLAB codes to compute the temperature of the dead body over a 10-hour period. First of all, we will define a function dt system with inputs time and temperature in an editor file named temp of body. Then we will define dt system equals to negative 0.12 times with t minus 15 and finally end the function. In another editor file named Newton graph, we will define the range of t as t span from 0 to 10, t naught equals to 36, and finally the format of the ODE23 built-in function, that is, time and temperature in square brackets equals to ODE23 at temp of body, t span, t naught. This file will then call the function temp of body from the previous file to solve the differential equation. Then we will proceed to plot a graph using the codes plot time against temperature in green. We will label the x-axis using x label and the y-axis using y label. Provide a title using the code title, and finally include grid on to have grids on the graph.
So let's see the second approach, which is Euler's method. Euler's method is the first-order numerical method to solve ordinary differential equations that we are able to use to approximate solution to an initial value conditions. The idea behind is to combine several small line segments using the concept of linearity to estimate the real curve. We can see clearly through the diagram. So this is the formula of the Euler's method, where h is a step size. Note that the step size must be small enough to get an accurate result.
For the Euler method, in an editor file, let's define k equals to 0.12, h equals to 0.5, t from 0 to 10 with interval h, then t equals to 0 size t to assign the values of temperature, t1 equals to 36 to set the initial value, and n equals to numeral t to fix the number of values of temperature. After that, we will use the for loop from index 1 to n minus 1, define the differential equation dt dt and 3i plus 1 to generate values of the temperatures and display the values using fprintf. To plot the graph, we use the code plot time against temperature in red, label the x-axis using x-label, and label the y-axis using y-label. Provide a title using the code title, and finally include grid on. To compare the graphs of the Newton's cooling method and the Euler's method, we will combine the codes of both the methods in a separate editor file named graph comparison and include the codes subplot 121 and subplot 122 in each method's coding to compare the graphs side by side.
Okay, let's move to the second question. Find the time of death of the victim.
We start by defining t in bracket t and k using the symbolic function since, then assign k equals to 0.12. Here we are going to use the built-in function dsolve. So for that we will have to define the equation 1 equals to diff t equals negative k times with t minus 15. The initial condition, which is the time you found the body, condition equals to t at time 0 equals 25. And finally, t equals to dsolve equation 1, comma, condition. To find the time of death, we use t equals to solve t equals 36. We are using the temperature 36 degrees Celsius because that is the temperature of the body at the time of death.
Let's run and let's see the result.
So now let's see the result. To find the temperature of body over time of period using the first approach, we have to create a function of a time of body, and this function we need the value of small t, which is stand for time, and capital T that is stand for temperature. So this is the formula this dt system, which we get from the formula of Newton's. And then to insert the value of time and temperature, we have to create another file named Newton graph. So let's see the coding for Newton's cooling method. So this is the coding. We define the t-span from 0 to 10. So we press F5 to run this coding. And we get 11 values of temperature. So this is the graph of Newton cooling method. Next, we move to second approach, which is using Euler method. This is a coding. We use the step size hash equal to 0.5, and we press F5 to run the coding. So for Euler method, we get 20 values of temperature. So this is the graph of Euler method that we get. Next, let's see the comparison between these two methods using the file graph comparison. The coding actually is the same from before. It is just we display two graphs in one page to see the difference easily. So let's see. Let's press F5. So from this graph we can see Euler method have higher accuracy than Newton cooling method. Now we move to a second question where we need to find the time of death. This is the coding that we use. So we press F5. So the result that we obtain is the expression of temperature. And when we insert the temperature is equal to 36, we get the value of time t. After that, we use evaluate t, that function, to convert the value of time t to decimal point like this. So that's all for the result. Thank you.
In conclusion, Euler's method have a better approximation in determining the temperature of a dead body over 10-hour period, because from the result before we can see that the graph of Euler's method is smoother compared to Newton method. That's all from us. Thank you.